Now the next topic is that is exponential growth. So this is the application of differential equation. Let P of t be a quantity which increases with t. Suppose at time t is equal to 0, P of t is equal to P naught. So the rate of increase of the quantity is proportional to quantity at the time t. So dpt over dt is proportional to quantity at the time t. That is, it is increases. So we take here k is positive and become k times p of t, where k is greater than 0. That is a sign of increase, positive. So here we will take the 1 by pt, d of pt is equal to k dt by variable separable method. So we get on integration d of pt, derivative of function, in the denominator is a function. So we get it is log of pt, which is equal to kt plus log c. So we take log term on the left hand side to make the problem easy. So we get log p of t minus log c is equal to kt. So log m minus log n becomes log m over n is equal to kt. On taking exponential, we get p of t over c is equal to e raised to power kt, exponential form. So p of t is formed into change exponential rate of decay and growth. Since k is positive, so it is a rate of growth, and if k is negative, then it becomes exponential decay. First here we will discuss the rate of growth of quantity with the time. So at t is equal to 0, V naught P of t is equal to P naught. Therefore, P naught is equal to C e raised to power 0, that is 1. So we get C is equal to P naught. So from equation 1, we get P of t is equal to P of naught, or P naught we can say, e raised to power kt, which is the growth of quantity pt at any time t. This is the rate of growth of a quantity with time t. This is the main application of the exponential decay or growth in the form of differential geometry. Now the problem based on rate and growth of decay. The population of a city increases at the rate of 2% per year. How many years it will take to double the population? So here let P naught be the population at present and after T years. Rate of population increases at 2%. Therefore, dP over dt is equal to 2% of P. That is, dP over dt is equal to 2 over 100 P. That is, dP over P of integration variable separable is equal to 1 by 50 integration dt as variable separable method. So it becomes log P is equal to 1 by 50 T plus log C as done in the article of exponential growth. So we get log P minus log C is equal to 1 by 50 T. That is, log P over C is equal to 1 by 50 T. That is, P over C is equal to e raised to power 1 by 50 T. That is, P is equal to C into e raised to power 1 by 50 T. At T is equal to 0, P is equal to P naught at the present time. So we get P naught is equal to C into e raised to power 0. That is, C is equal to P of naught. So P is equal to P of naught e raised to power 1 by 50 T. Now, if the population doubles, then P is equal to 2 of P naught. That is, we get 2 of P naught is equal to P naught e raised to power 1 by 50 T. That is, P naught cancel out and we get 2 is equal to e raised to power 1 by 50 T. That is, we get log 2 is equal to 1 by 50 T. That is, T is equal to 50 into log 2. So by substituting the value of log 2, we get 34.65 years. That is, when the population becomes doubled, time will be 35 years near about. So after 35 years, population becomes double. So this is the application of exponential growth of a quantity in the form of differential equation. Now the next topic is exponential decay. This is same as the exponential growth. Let m of t be the mass of product at time t and m of naught be the product at starting or initially, that is at t is equal to 0. So rate of decrease is proportional to given mass m, that is dm over dt is proportional to m. As it is decay of any quantity, so here we will take minus, negative, minus or negative sign. Negative sign indicates decrease of quantity. So, by using the same trend as done in exponential growth, we will get m is equal to m naught e raised to power minus kt instead of kt, which is the decay of, that is the exponential decay of a product or of a given quantity, and m naught is the initial value of product at the starting time. So this is the exponential decay of quantity. Now the problem based on exponential decay is a certain radioactive material has a half-life of 2000 years. This is called half-lifetime period. Find the time required for a given amount to become 1/10 of its original value. Now the solution is, let initial mass m naught and mt be the mass after time t. Then from rate of decay we have dm over dt is equal to minus km, that is decrease in quantity. So we get, after solving it, we will get m is equal to c e raised to power minus kt from the above article. So at t is equal to 0, m is equal to m naught. Therefore, m naught is equal to c into e raised to power 0. That is, c is equal to m naught. Therefore, after time t, m is equal to m naught e raised to power minus kt. Now we have to find, after t is equal to 2000 years, m is equal to m naught by 2. After t is equal to 2000 years, m is equal to m naught by 2, half the original quantity. So it becomes m naught by 2 is equal to m naught e raised to power minus 2000 k. So we get half is equal to e raised to power 2000 k after eliminating m naught. So we get, taking log 1 minus log 2 and log of e raised to power minus 2000 k, log and e are cancelled. So it becomes log 1 is 0 minus log 2 minus 2000 k log e. that is m raised to power n, m log n. Log e is 1, so we get minus log 2 is equal to minus 2000k. That gives k is equal to log 2 over 2000. So we get the value of k. Now we have to get the time period when m become 1/10 of original value. So at some time t, suppose m is equal to m naught by 10. Then from equation 1, m naught by 10 is equal to m naught e raised to power minus kt. So we get 1 by 10 is equal to e raised to power minus kt. Again taking log, we get log 1 minus log 10 is equal to minus kt log e. Log e is 1. So we get log 1 is 0. Minus log 10 is equal to minus kt. So we get kt is equal to log 10. That is t is equal to log 10 over k. That is log 10 over value of k is log 2 over 2000. So we get log 10 over log 2, that is log m over log n. So we can write log 2 into 5 over log 2 into 2000. That is log m plus log n over log 2. That is we get 1 plus log 5 over log 2 into 2000. Or we can say here that is the value of t is log 10 over log 2. That is right. We don't have formula for log 10 over log 2. So by substituting the value of log 5, that is 0.996, 0.699 and 0.3010 into 2000, we get 1 plus, that is 2.322 into 2000, that is 3.322 into 2000, that is divided by 1000, we get 4466 years. So we get these are the years when the original value becomes 1/10 of the